So the way to solve this kind of question is, you must first identify how much water are you dealing with. That's the first step. So how much water are you dealing with? Look at tank A. Tank A is completely filled with water. Completely filled with water, it will mean the volume of the water is equal to the volume of the tank. So the volume of water in tank A will be just the dimension, 10 times 20 times 50 of a dimension of tank A, you get 10,000 cubic centimeter. Now, volume of water in container B is 300. Volume of water in container C is 620. So therefore, to find the volume of water that you are dealing with in this question, the total volume will be just 10,000 plus 300 cubic centimeter from B and 620 cubic centimeter from C. So total volume of water we are dealing with here is 10,920 cubic centimeter. So the way to solve this question is to use the quantity value table. This table is not necessary, but it is very useful to help you visualize the information you have and help you to compute with lower risk of careless mistakes. So you see, so there's container A, B, C, base area, water level, and volume. The way I did this, I presented it this way is because base area times water level is volume. This multiplied by this is this. Okay, so it's like quantity value, total value, the quantity value table. So base area of A, all this information you can get it from the diagram here. So base area A is 10 times 20, 200, 8 times 5, okay, over here, 15 times 10, base area of C, 15 times 10, okay? So you got all the base area. Now, what is the water level? This is the water level that you are supposed to achieve. The question says that after pouring all this water into these three containers, your water level has to be equal. So all you need to do is 1, 1, 1. So this is very simple because the question says it's equal, 1, 1, 1. Sometimes the question may say, after pouring water from A, B, and C, I want to be poured in such a way that at the end, the water level of A, B, C is in the ratio of 3 to 1. Sound complicated, right? But it's simply replacing 1, 1, 1 with 3, 2, 1. So these are the variation this kind of question can be. So the variation can be changing the water level to unequal, to a ratio, to a multiple, or to a fraction of each other. Or for example, A is half of B, that will be 1 to 2. It can be 2 containers, can be 3 containers. It doesn't matter. Once you draw up this table, the solving of this kind of question becomes very easy. All right, so now in this question, very simple, they want the water level to be the same, so I just 1, 1, 1. Now, 200 times 1 is 200, and so on. 150 times 1, 40 times 1. Now, what does this table represent? This table represents one group. And what is one group meant in this context? One group meant one pour. So you have 10,920 cubic centimeter water. And every pour, each time you pour into A, B, C, you're going to pour 200 into A, 40 into B, 150 into C. So this is one pour. You must pour until you completely drain out 10,920 cubic centimeter. And if you were to pour it in this manner, every pour, the water level in each container will rise by 1 centimeter. That's what this table meant. And that is why this table is very important. Okay? So how much water is there in one group or in each pour? It is 390. You add up all these 200 plus 40 plus 150. So each group is 390 or each pour is 390. So how many times must you pour in order to completely pour out 10,920 cubic centimeter of water into A, B, and C? You just divide 28 times. So after pouring 28 times, the water level will rise 28 times, each time 1 centimeter. And what is the water level in A in the end? It will be 28 times 1 centimeter, 28 centimeter. Any question? Any question?